Shubhamangalam. My name is E. Venkata. I'm from 8th class. Today I'm reading chapter 1, Force from Science. Today I'm going to explain you 3 activities from this lesson. Force. We can observe many changes around us, like changes in season, change during sunrise and sunset, changes in tides of sea, etc. Have you ever thought about the cause behind these changes? In ancient days, people thought that an invisible force was responsible for the changes occurring in nature. Even now, many people believe that an invisible force exists that causes whatever is happening in the world. Later, the concept of force was developed, but it was limited to explaining our efforts and actions. The words force, effort, strength and power had almost the same meaning at the time. Have you ever wondered what forces are, what are they, different types of forces are, and how do they act? Let's find out the answers to such questions in the chapter. For instance, when you ride a bicycle, most of the time your legs are pushing down on the pedals to push you. Have you to make an effort? When you pick up your school bag, you have to make an effort in order to lift or pull the bag upwards and off the ground. When you open a door, you make an effort on the doorknob with your hands either to push the door forward or pull it back. What is force? Have you ever picked a heavy stone? How does a paper boy through a newspaper? Have you ever wondered about this action? Actions like stretching a rubber band, pulling a rickshaw, rowing a boat, etc. are some more examples where our efforts help to change the position or shape of the object. Such actions like picking, quizzing, twisting, stretching, lowering and lifting, etc. cause a change in the state of an object. Now let us try to group these tasks as a pull or push. Activity 1. Identify push or pull. Table 1 gives some examples involving the actions like digging, sucking, erasing, falling, attracting, rising, etc. Classify these actions in terms of a push or a pull or both. Write pull or push in the blank boxes. If you feel that the action involves both push and pull, write both in the box. Based on this activity, can you explain what is force? Shall we call the effort done on an object by means of pushing or pulling as a force exerted on the object? We cannot directly see the force acting on a body, but we can see the effects caused due to the force. When an object slips off your hand, it always falls down. What pulls it down? If you roll a ball on a level ground, it slows down and after some time it will come to a stop. What makes the ball stop? What forces acting on object change their state or state of motion? Types of force. Contact force and force at a distance, field force. Why does the toothpaste come out when we press the tube? Why does the needle of a magnetic compass move when I place a bar magnet near it? Have you observed the difference between the force you applied on the tube and the force applied by magnet on the needle of a compass? In figure 1, you observe that there is direct physical contact or interaction between your hand and the tube. Force which results when there is a direct physical contact between two interesting objects known as contact force. In figure 1b, the needle of the compass changes its direction without any physical contact with the bar of magnet, but a force must be acting on the needle. The force which occurs without any physical contact between two objects is known as a force, a distance or field force. Activity 2. Observe the magnetic force. Take a sewing needle, rub it with a bar magnet several times, always moving the magnet in the same direction. Does the needle get magnetized? You may find the needle always acts like a magnet with the help of a magnet compass. You can identify the north and south poles of the needle. Pin a red colored cork ball to south pole and white ball to north pole of the needle. Then drop it in a ball of water. It floats. Make another needle in the same way Float both the needles side by side such that like endings facing each other, either red or with white balls. What happens to the needles? How do they move? Now place the needles in such a way that unlike ends, white balls of the first needles and red balls of the second needle face each other. Now observing with what happens this time. How do they push or pull each other? You have learned in class 6 that like poles of the two magnets repel each other and unlike poles attract each other. You can observe the red end of the one needle and white end of the another needle attract each other and ends with the same color repel. Now you know that like poles repel or push each other away and unlike poles attract or pull each other. This action of pull or push arises due to a magnetic force. A magnet can attract or repel another magnet without contact. So magnetic force is a field force. Activity 3. Electrostatic force. Observing electronic force, take a balloon, inflate it and tie up and open end. Now cut a paper into small pieces and place them on the floor. Rub the balloon with a paper and bring the balloon near the piece of paper. What happens now? Are the bits of paper pulled towards the balloon? Why does the balloon pull or attract the pieces of paper? Try to use paper and salt in the place of pieces of paper. What do you observe? Thank you.